folks, and here comes the third recording for you, which is questions 21 to 30. And so I'm going to begin with obviously 21. And so in this case, they want you to find the range of the quadratic function. Now, remember the range is the y values. You always read them. So when you look at the drawing or the figure, you're always going to read the range going this way. So I'm coming from the bottom up. So this is always your first number in a sense of the interval. So this would be, let's call this, oh, I don't want to call it x, let's call it, let's call it a, and then it ends with b. B is whatever's up here. All right, so that's for the range. So anytime we talk about range, we're going from the bottom up. And if I'm talking to you about the domain always starts with the negative infinity from this side, from negative x all the way up to positive x for the domain. So in a sense, this is like negative y, positive y. If you want to think of it that way, that's fine too. All right, so I'm thinking in this case, if I'm graphing this equation and I'm looking at the range, let's find that axis of symmetry first. So on number 21, the way I would approach this is if I have f of x is equal to x squared plus 10x minus 6, I'm going to use negative b over 2a to find the x term of the vertex. So negative b in this case would be negative 10 over 2 times 1, which ends up giving me negative 5. And if I throw negative 5 into the equation, so I'm going to do f, let me switch the pen, f of negative 5, then this is equal to negative 5 squared plus 10 times negative 5, and then obviously followed by minus 6. All right, and so in solving this, I'm going to get 25 minus 50 minus 6, and this is going to give me negative 25 minus 6, which is negative 31. So that means that if I'm graphing this, I'm looking at negative 31 as a y value, as the bottom or the lowest part of this. If I'm at negative 5 for x, I'm going to be over here, hypothetically. So let's say this is what the negative 5 is. So I've got my vertex. This is opening up somehow this way. My vertex is down here. So that means the lowest part of this, of my range, is negative 31, and it goes up to positive infinity, always with a parenthesis. So it looks like for number 21, the answer choice is A. All right, let's look at 22. Question 22. 22 says, find the x-intercepts, if any, for the graph of the quadratic function. All right, so let's pull this over. Okay, so our equation is negative x squared plus 15x and the last term, the c term, is minus 56. So what we want to do is we want to try to factor this. So first things first, I'm thinking a c term is 56. I believe 8 and 7 would give you 56. So because this is negative, this has to be a plus minus situation. I'm thinking, however, that if I take the negative x squared plus 15x and minus 56, and I multiply the whole thing by -1, that, remember, this is equal to 0, so I can actually go ahead and do that. I'll get x squared minus 15x plus 56 equal to 0, which is going to yield me an x minus 7 times x minus 8 equal to 0. So I'm thinking my x-intercepts are going to be 7, 0 and 8, 0. Looking at this, it looks like your answer choice B would be the winner. All right, let's look at 23. In 23, same question. Now 23 is a little quirky because they're giving us, let's see here. So we have 2x squared plus 10x plus 5 equal to 0. All right, so even using the AC method, I couldn't use factoring, so I'm going to use a quadratic. So negative b plus or minus the square root of b squared minus 4ac, and all of this over 2a. So a is equal to 2, b is equal to 10, c is equal to 5. All right, and so minus b minus 10 plus or minus the square root of 10 squared minus 4 times a times c, which is 5, and all of this over 2 times a, which is 2 times 10. So this reduces to negative 10 plus or minus the square root of 100 minus minus 40, and all of this over 20. So first things first, obviously this is going to reduce to negative 5 plus or minus the square root of 60, and all of this at this moment is over, no, I'm reducing too quickly. Let me not do that. It's going to be too confusing. All right, let me go back. Remember, this is 100 in here. So we have 100 minus 40. So this is going to give us negative 10 plus or minus the square root of 60 over 20. And I'm already thinking of the center number to be negative 10 plus or minus the square root of 4, which is 2, times the square root of 15, which stays in the box, over 20. So if we reduce all of these by 2, this will cancel with this, and this will reduce to negative 5. This will give us a 2. All right, so I'm thinking that this solution should be negative 5 plus or minus the square root of 15 over 2. All right. And that means that the answer choice here should be, this is what number, 23? Answer choice for 23 should be C. All right, the next question, number 24. Kind of annoying having to go back and forth here. Let me see if I can push this over just a little bit. All right, for 24, they want you to determine if it has a minimum or maximum. In other words, is a vertex a positive or a negative? So for 24, what I would begin doing is if I have f of x is equal to 2x squared plus 4x, we're going to find our vertex by using negative b over 2a to get the x value of the vertex. So this is going to give me negative 4 over 2 times 2, hence negative 1 for the x. So we know that this is at least negative 1, comma. And now we're going to plug in to find f of negative 1. We'll find the y, which is equal to 2 times negative 1 squared plus 4 times negative 1. So this is going to give us negative 1 squared is positive 1 times 2 is 2 minus 4, which is negative 2. So our vertex is negative 1, negative 2. This definitely opens up. And because it opens up, and that could actually help you very quickly, our vertex would have to be a minimum because our vertex is sitting here in this area. If that is the case, and I have negative 1, negative 2 for number 24, let's see here. Just verifying. It looks like the answer choice should be C. It's a minimum. Minimum with a vertex of negative 1, negative 2. And we proved it. So that's number, what did I just say, 24. Okay, number 25. And number 25, you have 236 feet to enclose a rectangular region. What is the maximum area? So remember that if this is the perimeter, this is twice the width plus twice the length is equal to 236. If I divide by 2 on all three terms, I get width plus length, and now this is 236 divided by 2. That gives me 118. Okay, and now I can solve for length times width because I know that the area is length times width is equal to the area. And so I just need to find what the length and what the width are. So if these are equal, because you have no choice but to think of them as equal because they don't give you any other cutoff, let's take the 118 and let's divide it by 2. And if you take 118 divided by 2, you should get 59. And if you take 59 squared, basically 59 times 59, you should get 3,481 for the area, which is what this is. So this question was a little different. You guys are used to them giving you something else in terms of at least another measure. In this case is straight up equivalent for the width and the length. So that's 25. Okay, this next question is a little long, so let me open it up so you can read the whole thing. This is number 26. So you have an object that is propelled vertically from the top of a 240-foot building. They gave you the quadratic function. This models the height of the ball above the ground. They want to know how many seconds it takes for the object to hit the ground to the nearest second. All right, so we begin with this question. So f of t, oh, I'm sorry for this, guys. It's quite obnoxious. F of t is equal to negative 16t squared plus 208t plus the 240. And they're telling you that the building is at the very crest at 240 as well. All right, so let me go ahead and set this up for you. All right, ladies and gentlemen, so again, the way we set this up is because you're already at a 240-foot height. This is equal to the negative 16t squared plus the 208t plus the 240. And obviously you can see that the 240s are going to cancel. That's going to cancel out here and here, leaving you 0 is equal to negative 16t squared plus 208t. And we're going to divide, in this case, all three terms by negative 16. This is going to leave you with t squared, well, 0 is equal to t squared minus 13t. If I factor the t out, so let's I factor the t out, I'm going to be left with t minus 13, which means that t is either equal to 0 or it's equal to 13. So as we look at this question, you can see that the closest answer would be A if you did it this way. You can also take this question, which would be my preferred method for you to use. And so this is actually S of t, not F of t. I don't know, I'm so used to writing function. This is equal to negative 16t squared plus the 208t plus the 240. If you were to divide by negative 16 on all three terms, you would probably get the exact answer. So let's try it that way. This is going to give you positive t squared minus 13t, and we're going to take that 240 and we're going to divide it by divided by 16, so you get negative 15, and we're going to use a quadratic formula. I'm thinking if a is equal to 1, b is equal to negative 13, c is equal to negative 15, we're going to use negative b, negative 13, plus or minus the square root of negative 13 squared minus 4 times 1 times negative 15, and all of this over 2 times 1. So let's go ahead and simplify this, and let's see if this gives us the exact 14.1 I'm looking for. So I'm going with 13 plus or minus the square root of 169 plus 60 all over 2. Okay, so this is giving me 13 plus or minus the square root of 229 over 2. Okay, this is not looking much at this moment. My confidence is waning. So if I take the square root of 229, does that give me a number that I can use? It does give me 15.132. Let me see if I can pull out a perfect root from that. So revisiting this, I'm not going to complicate matters because you're not going to have a lot of time on this test. So let's go ahead. The square root of 229 is all of this, the 15.13. You can round it, not round it. It's up to you. I would go out at least 4 decimals. When I do that, I did 13 plus the 15.13 and change. Obviously, it's not going to be the negative 13 minus, because the negative 2 divided by 2 will give you negative 1, and there's no such thing as negative time. So this does give me, as a sum, if I do the plus only, a 14, after I divide it by 2, I get 14.066, which I would round to approximately 14.1. And that's how we obtain the exact answer for that question. That would be probably the better or more secure way of doing it. If you do it like this, you're kind of guessing, and if you have an answer that's close to 14.1, say they give you a 14.1 and a 13.9, how would you know which way to go? So I would definitely use the second method I just showed you. It's more secure. All right, so I'm testing the waters to see how your logic is going to go, giving you options and ways to think. All right, here's number 27. For number 27, we can actually just use the question. So in terms of the gist of the question, they want you to solve the inequality, and in essence, solve for the parameters for the domain. So in this case, I'm looking at testing intervals. That's what I'm thinking for this one. You can always substitute if you're in a hurry or you have doubts about how you approach the question like this. So you can always plug in a number and make sure that it works. So we're on number 27. I have x cubed plus 6x squared minus x minus 6 greater than 0. Okay, so I'm going to factor by grouping. I'm going to pull out the x squared. This is going to leave me x plus 6. And over here, I'm going to take away a 1, and that leaves me x plus 6. And this has to be greater than 0. So my two factors are x minus 1, x plus 1. Obviously, we know that this and this are one factor, right? So that becomes x squared minus 1, which simplifies down to this factorization. And the second factor is just your x plus 6. So this is the third one down here, the x plus 6. So if I'm thinking of a number line, I'm thinking that x is equal to 1, negative 1, positive 1, negative 6. So I'm going to test on the number line those three values and the 4 intervals it creates. So this is the one where we have negative infinity on the left and on the right positive infinity. We start with negative 1, positive 1, negative 6 over here. In red, as I've always done in class, my test number. So I'm going to test 0, I'm going to test 2, I'm going to test negative 2, and I'm going to test negative 7. All right. So what we need to do then is substitute in those numbers into the equation. So if I start with negative 7 cubed plus 6 times negative 7 squared minus 7 minus 6, is that greater than 0? And your resounding answer should be no. This obviously results in a negative answer. So no to this interval. This interval from negative infinity to negative 6, not an interval that we want to use. And remember, these are not inclusive because there is no equal to sign. Okay. Let's test the negative 2. So negative 2 cubed plus 6 times negative 2 squared minus negative 2 minus 6, is that greater than 0? Is that greater than 0? So this is going to give me negative 8 This is going to give me plus 24. This is going to give me positive 2. I'm already thinking, yes, this is going to be greater than 0. So this is definitely a positive number. So the interval from -6 to -1 is good. Okay, now we're going to test the interval. This happens to me all the time while I'm recording, or even when you guys don't come to office hours and I'm sitting idle waiting for you. So I have to go back, turn it back on. So sorry about the interruption, but I'm glad you saw this so you understand sometimes when you pop in and I'm not immediately available, but I do come on, it's because of this. So let me just set this back up again. I got another 45 minutes or so. Make sure this took, yeah. All right, so at least I can hear you when you come in. Awesome. All right, so where am I? I'm here. So now we're testing the interval from -1 to +1. So I'm testing the 0. So I want to know what 0 to the 3rd power plus 6 times 0 to the 2nd power minus 0 minus 6, is that greater than 0? 0, 0, 0, -6 is not greater than 0, so no to this interval. Okay, and now we do the last one. The last interval is -1 to positive infinity, and I'm using the 2. So we're going to test it with 2 cubed plus 6 times 2 squared. Looks promising. -2 minus 6, and that has to be greater than 0. So this is 8. Again, 2 squared is 4 times 6, 24. 24 minus 8. I think we're good. It's definitely greater than 0, so this is another winner. So it looks like for number 27, I'm thinking this is going to be answer choice C. Pay attention to these questions because sometimes they'll put a bracket on one just to throw you off. Just be sure that they are parentheses in this case. All right, number 28. Let's read the question together here. And it says, a ball is thrown vertically upward with an initial velocity of 192 feet. This question is old. We've done this question a million times. The distance in feet of the ball from the ground after t seconds is s is equal to 192t minus 16t squared. It says for one interval of time is the ball more than 560 feet above the ground. All right, so here's the setup. Okay, so in this question, they tell us that the ball has to be above the ground. So the key here is when you set up the equation, you're going to start with your 192t minus 16t squared. It has to be above the ground, so greater than 560. So we're going to subtract the 560 and bring it over here, and we're going to reduce it over here. So I'm going to subtract 560 on the right and bring it as a negative over here to the left. So my equation is now, and I'm going to rearrange this, putting the negative 16t squared in the front plus the 192t minus 560 has to be greater than 0. All right. And what we want to do is we want to divide by all three terms, including the 0, which really doesn't matter, by negative 16. Okay, and what happens is you end up with positive t squared plus, minus 12t, and this becomes positive 15. And that has to be greater than 0. So I need to factor this out. Let me double check that. 560 divided by 16. Actually 35, my bad. My mistake. By 35. So two numbers that multiply to give me 35. I'm thinking 5 times 7 because that'll also add up to give you 12. So I get t minus 7 and t minus 5, obviously greater than 0. So my two solutions would have to be 7 and 5, or 5 and 7 respectively. So I'm thinking for number 28, your solution for number 28 should be A. I'm thinking it's A. It is A. Awesome. All right, number 29. So here's number 29. Number 29, the profit that the vendor makes per day by selling X pretzels is given by the function where the profit function, P of X, is equal to negative 0.002x squared plus 1.2x minus 400. Find the number of pretzels that must be sold to maximize. Whenever you see the words either minimize or in this case maximize, solve for the vertex. So we're going to use negative b over 2a. Negative b is negative 1.2 over 2 times negative 0.002. All right, and so using your calculator, let's see here. The negatives are going to cancel anyway. And this is going to be I'm getting 300 pretzels for this. And for number 29, according to this, okay, let's see what the key says. Yeah, the answer choice should be D. It should be 300 pretzels. Okay, find the y-intercept for the graph of the quadratic function. So in this question for number 30, they're giving you f of x is equal to x minus 3 squared minus 9, okay? And if x is 0, so basically you're looking at f of 0, that's going to give you negative 3 squared minus 9, which is going to give you 9 minus 9, which means that f of 0, when x is 0, y is 0. It looks like for number 30, your answer choice should be A. All right, so that's the numbers, what did I say, 21 to 30? I'm going to record the next few in a minute.